the practice we want to do in this video, we cover the following topics. We cover Hooke's law. We'll cover Hooke's law, generally elasticity, the energy in the work done. Another one we talk about conductors and insulator. Another one we talk about resistivity, resistor and ohms. Another topic we are going to talk about here as a practice question, energy and power. We'll talk about the energy that we consume at home, household or household energy, how we use energy as a kilowatt hour in our various houses. And likewise, we'll talk about energy in form of potential energy. We'll talk about force in form of weight, or generally we'll talk about it as a force. We'll also talk about it as a weight, or the force towards the earth. We'll talk about speed. We'll talk about power. We'll talk about the instrument to measure the spring, to measure the force. We'll talk about acceleration. We'll talk about derived quantities, and we'll talk about how to measure the diameter of wire. These are the headlines we have in this video, and let's start without wasting time. We can have a question that may talk about the measurements of the diameter of wire. Now we have a video on this, on a topic called measuring instruments. That topic is majorly meant for the beginners class of physics, year 10 or SS1, and how you call it. We have length, we have meter rule to measure the length. We have micrometer screw gauge to measure the diameter of a wire. Please take notice. That is, if you want to measure the diameter of a wire, you will use micrometer screw gauge. I think that one has settled that headline. And we have other measurements, a measuring instrument. Your stopwatch measures time, and so on, because of time. Now from there, let me move to Hooke's law. We know Hooke's law. We say Hooke's law states that provided the elastic limit is not exceeded, the extension of the spring or the extension of the elastic material is directly proportional to the load or force applied. We have a lot of videos on Hooke's law and elasticity. Please do well to watch and get it right from there, because questions are also coming from those videos. Because remember, we want to assess you based on how you have been with us on this platform. This is an educational platform where we learn. We want to really know, are we passing information rightly to you? Are you also receiving it rightly from that end? So with that, now on Hooke's law, what are the possible questions they can ask you? We have stated the Hooke's law, which means that F equals to KE. The force, F is the force or the load. The K is the spring constant, while the E is the extension. Extension is measured in meter. If you are given a centimeter, you convert it to meter. I'm going to give you a question right now. You are going to answer the question and drop your answer in the comment box, and for me to confirm if you are right. Assuming you have a force of 10 Newton and you have extension of 5 centimeter, what will be your spring constant? Drop your answer in the comment box right now. You can pause the video to work to solve it and continue watching. What am I saying? I repeat again. I said if the force of 10 Newton, if the force is 10 Newton, that's F 10 Newton, and the extension is 5 centimeter, what will be your spring constant? I'll be expecting your response in the comment box. As we leave that side, I move to the energy stored in the elastic materials, or energy stored in the spring. The formula is half W equals to half Fe. If you are given F in the question and E, you use that formula. But if you are not given F, which is force, and extension in the question, that you are only given K and E, your formula that you are going to use is W equals to half KE squared. The K is the spring constant. So from there, I'll also drop a question to back that one up. I'll call the question, you drop your answer in the comment box for me to assess if you are right or not. Assuming that you have your energy of the spring as 0.9 joules. Please do well to press the subscribe button, turn on the notification button, like and share very well, and likewise turn on your subtitles so that what I'm saying you'll be able to be seeing it coming up on your screen. Since I'm not writing, I'm not showing you any visual write-ups. All right, if my energy is 0.9 joules and my spring constant is 150 Newton per meter, what would be the extension? Drop the answer in the comment box. I repeat, the energy in an elastic material is 0.9 joules and the spring constant is 150 Newton per meter. What would be the extension? I think that one settles the issue of Hooke's law. I can move to the next topic to discuss. I want to move to the discussion of conductors and insulators. When we talk about conductors, or conductors are materials, let's say that, or substances that allow electricity to pass through. That is, it shows that is electrical conductor. That means that when you talk about electrical conductor, they allow free electrons to flow. They allow electron, because electricity means flow of electron. Current means flow of electron. As that is, any material that allows the flow of electron is called conductor. The opposite of conductor is insulator. Opposite of conductor is insulator. Let me see if I can have something like that. Example of conductor can be that all metals are conductor. In case you don't know, human body is a conductor. That's why you must not joke with electricity. Water is also a good one. Don't joke. Water and electricity must not come together. That is, I mentioned an example. In case they may give a lot of examples, they say that which of the following is an example of conductor, and they put maybe aluminium, stone, whatever. You know that aluminium is the answer there. For the issue of insulator, also insulator is a substance that does not allow electricity to pass through. A good example is wood. That's talking about insulator. I think I have settled the issue of conductors and insulator. I want to move to let me move to speed. When you talk about speed is distance over time. Speed is distance over time. Let's assume that you are given a question that you should convert 72. Okay, let's say you are given a question like you have to convert 72 km/h to meter per second. Now I'm giving it to you right now. Put your answer in the comment box. Convert 72 km/h, that is the speed, to meter per second. And put your answer in the comment box for me to confirm if you are right. Still on that note of speed and the likes, you can also have acceleration. Acceleration means the rate of change in velocity. I have mentioned the rate of change in velocity. If I don't want to mention rate, I will say acceleration is the change in velocity per unit time, and the unit of acceleration is meter per second square. I think that was settled the issue of acceleration, and likewise I've settled the issue of speed. And likewise, you need to know, I want to settle the issue of density. When I talk about density is the ratio of the mass to the volume. That is, the unit of density is kilogram per meter cube. Kilogram over meter cube. Kilogram per meter cube. I have settled that. So moving forward again, I'll move to force now properly. When you talk about force, force is the product of mass and acceleration. That is, force is equal to mass times acceleration. And I'm giving you another question right now, which I want to put the answer in the comment box. If you are given a mass of 4 kg and acceleration of 3 meters per second, what will be the force? Put the answer in the comment box. And I need to tell you that the unit of force is Newton. The unit of force is Newton. I think I have settled that. And the last thing I want to settle at this session before I'm done that thing is that we know how can force be measured? You check in our various houses, we have cylinder of gas that we use gas to cook at home. You go to fill your gas, they use the spring balance to measure the weight of your cylinder, and likewise the gas you are filling in. So what are we saying? That the spring balance measures the force. The spring balance is an instrument used to measure the force. I've told you that one right now, that the instrument used to measure force anywhere in the world, the spring balance. I think I have clarified that one. Okay. I think I need to let you know that when you talk about, we can also talk about gravity. I need to let you know that gravity is the force that pulls object towards the earth. What are we saying? Have you noticed that whenever you jump up, you still come down? Anything that goes up comes down. Why? Because of gravity. That is, gravity is the one in charge. That is the one attracting any object. Gravity is the one attracting any object. So that's talking about the issue of gravity. And I think we have used that one to settle the issue of force. I can move to I think I've told you that we meter rule to measure length, and the unit of length is meter. The unit of length is meter. And let me talk about energy. If you talk about energy, we can talk about energy in several ways. If I talk about energy in form of potential energy, that is energy that is found in the body at rest. When body is at rest, when body is at a position, the energy you found in it is potential energy. And the formula for potential energy is mgh. mgh. Now, I'm giving you a question right now. If your mass is 2 kg and your acceleration to gravity, your gravity is 10 meter per seconds, and your height is 5 meter, calculate the potential energy. I repeat, your mass is 2 kg, your gravity is 10 meter per second square, and your height is 5 meter. What is the potential energy? Drop your answer in the comment box. And think that one settled that one. That one settled the issue of potential energy. I think I can now move to let me move to, before I move, okay, kinetic energy. What about kinetic energy? A body is moving. The energy inside that body that is moving is kinetic energy. I think we have settled that one. And likewise, when I was mentioning the issue of conductor and the insulator, I supposed to mention that we have some material we call magnetic materials. Any material that can be attracted by magnets is called magnetic material. So definitely any material that cannot be attracted by magnet is called non-magnetic material. So definitely a good example of non-magnetic material is a plastic. That's why I can say plastic is not a magnetic material. Plastic is not a magnetic material. Still on the issue of energy, I want to let you know that potential energy is stored in a stress string. I suppose I've talked about this one when we were talking about Hooke's law. When you are stretching your string or spring, well, I repeat, when you are stretching your spring under the Hooke's law, the energy inside is still potential energy. And then you want to ask me why. The height, the distance. So potential energy is stored in a stretch string, and that one is settled. I think I can now move to let me move to energy we use at home. When you talk about the energy we use at home, definitely we are talking about kilowatt hour. The unit of energy is joules. Everybody knows that one. So what about the energy we use at home? Our electricity that we use at home, the unit of energy, that one is kilowatt hour, is the energy there. Take an instance. If I give you a question, let's assume I have a question like let me see if I can bring up a question. If I have a question like okay, I have a question. If your power in a bulb or in any device, you have a power in a particular device has 60 watts, and the time that particular device, maybe the bulb, the time you use that bulb every day is 5 hours. I repeat, the power is 60 watts, the time is 5 hours. The question is now telling us that what would not be your energy for 10 days? For per day, we have 60 watt power and 5 hours in a day for that thing to be used. Now, for 10 days, what will not be the total energy? That's what they're asking you, and put your answer in the comment box for me to confirm your answer. I think I've settled the issue of potential energy. I can move forward to electrical power. I'm now in electricity proper now. When you talk about electricity, you need to recall from your Ohm's law. I'm taking you back to the Ohm's law. The Ohm's law states that the steady current passing through a metallic conductor is directly proportional to the potential difference, provided all other constants are kept constant. Indirectly, what are we saying mathematically? V equals to IR. Your V is your potential difference, your I is your current, and your R is your resistor or resistance. V is equals to IR. Question can come from any angle, and that's the formula for Ohm's law. So, and from that formula, we generated the formula for electrical energy and electrical power. And from the formula for electrical energy, we know we have IVT, I square RT, and we have what again? V square T over R. That is talking about electrical energy. What about electrical power? Electrical power, just all those things I mentioned, just remove the T. That's what we call the electrical power. I'm giving now the question right now. Let's take an instance. If your current is 2 ampere and your resistor is 10 ohms, what will be the power? I take it again. If the current is 2 ampere, and the resistor is 10 ohms, what will be the power of that device? Put your answer in the comment box as we continue. Still on that same note of electrical energy and electrical power, I'm dropping another question right now, which I want you to put your answer in the comment box. In this time around, I want you to find current when your power, the power given to you is 600 watts and the potential difference, which is your V, is 240. I repeat, given that the power is 600 watts and the potential difference is 240, what will be the current? Drop your answer in the comment box for me to confirm your answer. If your power is 600 and the potential difference is 240, what will be the current? Please do that and put your answer in the comment box. I think we have settled that. I need to let you know, I said, I'm repeating again, power is the rate at which work is done. Power is the rate at which work is done. That's why we can say power is equal to work over time. That's how we discovered that formula that we are using. Now I want to move straight to resistors and resistivity. When you talk about resistors, you know, resistors can be arranged in series, can be arranged in parallel. When resistors are arranged in series, you add them together. That is R total equals to R1 plus R2 plus R3. But when they are arranged in parallel, it will be inverse. That is 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. To confirm what I just said right now, I'm bringing out a question. I want you in a circuit, this circuit now, in a circuit right now, we have 3 ohms, 6 ohms, and 9 ohms. 6 ohms, 3, I take it again. We have 3 ohms, 6 ohms, and 9 ohms. They are connected in parallel. I repeat, 3 ohms, 6 ohms, and 9 ohms. They are connected in parallel. Calculate their total resistance and put your answer in the comment box for me to assess you. And another one to back up that of series. I have a resistor. I have the following resistors: 4 ohms and 6 ohms. They are connected in series. 4 ohms and 6 ohms. They are connected in series. What will be their total resistance? Put your answer in the comment box for me to access. Leaving that side again, I move forward to what are those things we can experience when resistors are connected in series and when they are connected in parallel. Take notice of what I'm saying. When resistors are connected in series, the current is the same. I repeat, when resistors are connected in series, the current is the same, which means that the voltage is different. But when resistors are connected in parallel, the voltage is the same while the current is different. Take notice of those words. If you are not getting it right, you can rewind and play again to watch. Don't rush, don't skip any part. Take your time to watch. If you don't get what I'm saying, rewatch again till you get it right. Since you are preparing for a particular examination, a particular quiz, this is your time to be on, also to prepare yourself for that examination. I think I've clarified that one. Current is the same in the circuit for series, while for parallel, voltage is the same for parallel. I think I have settled that one. What again I need to let you know, in Ohm's law, temperature is kept constant. That's why when I was taking that law, I said provided all other factors are kept constant. One of those factors that are kept constant in Ohm's law is temperature. Temperature is kept constant in Ohm's law. I have clarified that one with you. What again can we say about resistor or resistance? Factors affecting resistance. Number one, length of the material. How does the length affect the resistor or resistance? The higher the resistance, the higher the length. That is, increase in resistance will bring increase in length, or we will say increase in length of the wire will bring increase in the what? In the resistance. I have mentioned the word increase. That is, as resistance is going forward, the length also will go forward. I have clarified that one with you. You know, if they also talk about other factors that will affect resistance, we have area. But how will area affect resistance? The higher the resistance, the lower the area. The higher the resistance, the lower the area. If it is resistance and area, That's what we call inverse. All right, let me stop that one there. I think I've clarified that issue of increase and increase about. I said resistance increases as the length increases. All right, I have said that one. What again can we notice? You know, we said we have series connection, we have parallel connection. From your view, even using the same value in total series, in series connection, using the same value in parallel connection, what is the difference between series and parallel? The difference between series and parallel is that the total resistance in parallel connection will reduce. Take an instance, you can try with numbers. Maybe you try with 2, 3, 4 as your resistors. Try them in series, try them in parallel, and you see what the answer will be. That is, when you are adding up, when you are gathering your resistors in parallel, the total resistors will reduce. The answer will reduce. The answer you get to be smaller than those values you have. But for series, as you are adding up, the thing will be increasing. I have clarified you. For that is, in parallel, total resistance will reduce. In series, total resistance will increase. Take notice, especially those of you that are writing post UTME, that you are writing NECO. That's an opportunity and a key point for you. I've clarified that one. I think I can move to what again? I've talked about current is the same through all the components. That's talking about series. Wow. And gradually I'm rounding off. What can I say about resistivity? Resistivity depends on material and temperature. I repeat, resistivity depends on material and temperature. Please do well to watch our video on resistivity. And what's the unit of resistivity? The unit of resistivity is ohms meter. The unit of resistivity is ohms meter. I have clarified that one with you, and we can move to the next thing. I want to move to diffusion. You know when you talk about diffusion, diffusion is talking about the movement of molecule or whatever you call it from the region of higher concentration to the region of lower concentration. You know, in your kitchen, when someone is cooking, someone in the kitchen is one that will perceive higher concentration than you that you are in the living room. Telling you from higher to lower is what we call diffusion. And let me be rounding off with this one. I will be rounding off with the issue of fundamental quantities and derived quantities. The derived quantities are the quantities that are produced or obtained from fundamental quantities. I think with this I have done well to help you in your examination and your quiz. The practice question settled, trusted, tested and trusted, done and dusted. I'll be very glad to see you in my next video. But before then, please do well to turn on your notification button in case of any information. Press your subscribe button, press your like and share button, put your comment in the comment box, share the link with your friends, and I'll be expecting you in my next video. Do well to watch all our videos. They are meant for you. God bless all of us. Bye.